Good morning, guys. Welcome to Algebra today, and we're going to keep talking about conic sections. Today we're looking specifically at parabolas. So first off, go ahead and do these bell ringers on your bell ringer paper. Send a couple of volunteers up to the board to show the work, and then we will compare our answers when we're done. So pause this video till everybody's ready, and we'll compare our answers when you're done. Okay. So we need to remember that the equation for a circle is given by x minus h squared plus y minus k squared equals r squared. So the x-coordinate represents our h value and the y-coordinate represents our k value. And so I'm going to substitute those in. I'm going to have x minus negative 5 squared plus y minus 3 quantity squared equals 2.5 squared. Simplifying a little bit further, I should get x plus 5 quantity squared plus y minus 3 quantity squared equals 6.25, because remember that means I'm doing 2.5 times 2.5. So there we go. That should be our answer for the first one. For the second one, find the center and the radius of the given equation. So remember that this is our x-coordinate of the center, and this is the y-coordinate of our center, and we have to do the opposite sign. So it starts out as negative 2, so for my center, it's actually going to be a positive 2, and for my y value, it's going to be a negative 7. So this is the coordinates of my center. And then we're going to use 169 for our radius, but the radius is not 169. The radius is the square root of 169, which is 13. So there are our two pieces of information. Pause the video if necessary, make sure everybody's got it copied down, and then we'll move on. So we're looking at parabolas. I know we looked at parabolas last semester, but we looked at some more technical parabolas. Here we're going to focus on some different parts of the parabola. We're going to look at the focus and the directrix. So the focus is the point that's inside of the parabola. If my curve is like this, it's always going to be inside the curve. And it is telling me that to get from the focus to the parabola is the same distance as from the parabola to my x-axis. I know it says directrix here, but in general it's going to be the same distance from the parabola to the x-axis. So these are just some magical points for us. And the directrix is a fixed line. It's always going to be outside of the parabola, and it won't ever cross. It's never going to come like this or like this. It cannot cross the parabola. It should always be outside. Kind of wherever the vertex is, it should be below that or beside it, and we'll look at that here in a second. So we've looked at parabolas of this kind and this kind, where we have an x squared value. But now we're going to throw in some parabolas that can open to the right and to the left. And what's going to happen there is that now it's going to be our y variable that is squared. So we are going, for this lesson in this unit, we are going to put our squared variable first all the time. So here are our four formulas. And then it's always going to be x squared or y squared equals 4 if it opens in a positive direction, like to the right or up, or negative 4 if it opens in a negative direction, like to the left or down, times a. Now a just means how far away is the focus from the vertex. So see that a value keeps coming into play here. And then it's also the equation for our directrix. So our directrix, you see here, it's an x equals because it makes a vertical line. Here it's a y equals because it makes a horizontal line. And notice that between the focus and the directrix, they both use that a value, but they're always going to be different signs. So one's going to be positive, one's going to be negative. Positive, negative. Negative, positive. They always have to be different. So pause the video so that you can draw. You need to draw these sketches. You need to know your equations, your four equations. And I would go ahead and label your focus and directrix on all of them. So there should be plenty for you to write down there. And then go ahead and hit play when you're ready. So the first example says, write an equation of a parabola with a vertex at the origin and a focus at 1/2, 0. So first I'm going to say, I know that if I graph this, my focus is going to be, let's say that this is 1 here, my focus is going to be right here at 1/2, 0. So my parabola has to open around it, so it's going to look like this. If I open to the left or to the right, it's going to be a y squared. And then I know that it's opening in a positive direction. It's opening to the right, that's a positive direction. And so my ultimate answer should be positive. So let's see what we've got here. We've got y equals, it's always 4, times, this value right here is my a value. So times 1/2 times x. Simplifying a little further, I've got y squared equals 2x. That is my equation. Let's look at another one. Write an equation of a parabola with a vertex at the origin and a focus at 0, -3. All of our parabolas for this unit are going to have a vertex at the origin, which makes things a little easier, but it's got a focus this time of 0, -3. So that means over 0, down 3. And so my parabola's got to open down around it, which means that it's got to be an x squared, and I know that my final answer has to be negative. But this is my a value, so I'm just going to put equals 4 times -3 times x. So I'm going to get x squared equals -12x. Or sorry, that should be a y. And that would be my final answer. X squared equals 12y. Let's do some graphing, everybody's favorite thing. So identify the focus and the directrix of the graph of the equation y equals 1/12 x squared. Then sketch the graph. So I need to first put this in terms of my squared variable in order to do this problem well. So I've got y equals 1/12 x squared. I could say, I'm going to divide by 1/12, but that's a little messy and complicated to divide by a fraction. Instead, I'm going to multiply by the reciprocal, in this case, which is just 12. So that's going to give me 1 on this side, and over here, I'm going to end up with just x squared equals 12y. Now, I need to find the focus and the directrix, so I need to find my a value. So remember that it's x squared equals 4ay. So really, this number right here has to be 4 times whatever my a value is. So I'm going to use that and say 12 equals 4 times a. Well, if I divide both sides by 4, I'm going to get a equals 3. So that means my focus, let me stop for a second and come over here. If I've got x squared and it's a positive, I know it has to open up. So my focus is going to be somewhere in here. So I'm not going to move left or right. I'm going to have 0 here, and I'm going to move up 3. And then my directrix is going to go straight across like this. So my directrix is going to be, since it's a horizontal line, I don't need the parenthesis. It's going to be a horizontal line, so it's going to be y equals, and then the opposite sign of this, -3. So there's the first part. We found the focus and the directrix, and then we're going to sketch the graph of focus of 0, 3, and a directrix of y equals -3. And then this is going to be your favorite part right here, I think, because remember last semester we had to find a minimum of 5 points. Well, today our vertex is going to be at the origin, and I'm just going to swing it around like this. Swing it around like this, and that's my parabola. You are welcome. It should make a parabola shape, but the main things we're looking for are the focus and the directrix, and saying, okay, I know that the focus has to be within the parabola's curve. Let's try another one. Identify the focus and directrix of the graph of the equation x equals 16y squared, then sketch the graph. So again, I have to have it in terms of y squared, not of x. So I'm going to start by solving for y squared. I'm going to divide both sides by 16, and I'm going to get y squared equals 1/16 x. So there's my equation. If I think about this, it's a y squared and it's positive, so I know it's got to open to the right. And I need my a value. So for my a value, I'm going to take 1/16 and set it equal to 4a. I'm going to divide by 4, but really that's the same as saying I'm going to multiply by 1/4. And so when I do 1/4 times 1/16, I'm going to get a equals 1/64. So again, parabola opens to the right, so my focus is going to be somewhere here. It's going to be moved to the right 1/64 and up 0. And my directrix this time is going to make a vertical line. So it's going to be an x equals -1/64, because again, these have to be opposite signs. This is a little bit more tricky to graph just because those values are so close to 0, but we're going to give it our best shot. We're going to have the point 1/64, 0, and then a directrix of x equals -1/64. And then your favorite part of graphing that parabola, just swing it out and around. And there you go. That's the problem. All right, so your homework is this. Take your time, work with each other, ask questions, and it will be checked tomorrow. So come prepared to have that checked and send me any questions that you have if you can't figure them out. And you can also check your answers in the binder when you're done. Thanks, guys. Have a great day.